Hello again. Let's just dive right in. You see cork has been laid onto the lift gate. I ran the feeders all the way across between the two ends. So what will happen is that a portion of rail up to here will be controlled by the lift gate, so that there's only really one micro switch that will turn the track off and trains can stop here without falling off the gate. And so to do the contacts, I use just normal flathead screws, and I feel like I'm going to regret this later. But I didn't have any brass or copper sheeting or sheets or something. Really, I wanted to do something with springs. Maybe later I'll revisit this because it might need to be revisited depending how much wear and tear the gate has. And same thing happened here. And there is the micro switch which cuts off the power to one rail, and the turnout here. So basically this three-way goes dead. Well, it's dead right now. It goes dead when the gate is up, and so the power gets transferred to those screws there. And there it is, connected down, and now the power is, or should be running. Hasn't been tested yet since there is no track on the bridge yet. So, next step, track laying. It's not without its challenges. Here is the point where the track is cut. It's a pretty tight clearance, and you can see it's tacked down with Eileen's tacky glue over there. It's just tacked to keep the track from moving while I'm working on laying the track down. And on the other side, there is the nature cork. It nicely lines up with the cork on the lift gate. The only problem is that if I remove those flathead screws I showed earlier, the gate will be lowered by probably a couple of millimeters, maybe 1/8 of an inch, and then everything will have to get redone somehow or rebalanced. Well, later on in the day, here is more progress on the lift gate. Track's down, it's been nailed down, and now the gaps on the other side are pretty close as well. The other piece of track is just stacked down, and the steel weight is keeping it down until it dries overnight. But I think it looks good. The gate still works. It goes up and down, and the track or the rails line up, which is a success. I left the cork in this area on the gate wider because I was thinking maybe I will add another track here and extend it to the other end. Maybe I will turn the staging into a mini yard. I've been watching Art Houston's videos from years ago, and he talks about his staging and how one of the yards there is actually a working yard where trains are put together and taken apart, and they serve the industries on the layout. So potentially, you know, a hostler or someone could work this yard, or maybe 2-3 tracks in this staging yard and make it more interesting, I guess, for that person rather than just standing there and dispatching trains. I don't know if that's even necessary. I mean, this layout is not that big and it will probably only have 3 operators the most. So having a yard hostler or a staging hostler there might just be overboard. By the way, I got these feeders hooked up as well and on the lift gate. So really, it looks complete. The other side to the right is not wired yet, so probably a feeder there, and that rail will disconnect somewhere around that area and trains will stop if they by some fluke decide to take a dive if the gate is in the upwards position. By the way, I use the HO cork because I'm thinking I'm going to use the HO cork on the main line and then the N scale cork over there just for the sidings. I think it will look nice visually when the rail is elevated from the main line. But I'm not there yet. There is still a few more things that need to be done before I get to laying the track down, although of course I'm itching to run some trains. Let's switch gears now. Let's play with the mainline electricity. We're going to be modifying one of these LED lights to be a shorter one. They are 4 feet in length when you buy them at the store, and unfortunately they don't make anything shorter than that. We got them because they were nice, low profile, so they kind of they hug the ceiling and they don't take much space vertically. But in this area over there, or here, it's kind of dark, so we need more light. This one that's right there, it's gonna be moved all the way to the end, and then a shorter one is gonna go here, probably 3 feet. So the task for today or the next few days is going to be to shorten this to 3 feet or whatever fits in that space. So I've already done a bit of work. This light has 190 LEDs and they're paired, so there is 95 pairs of 2. The pairs are in parallel and then 95 pairs are put in series. And this is the controller board. It's probably a generic board. It's as generic as it can get. And I don't know if I can actually zoom into this. This is just a phone camera. So this chip here is a booster chip. It's a standard whatever OEM chip, and the manufacturer provides a data sheet, which is really a joke because there is no data on it. There is some basic information about their chip. You can see low cost boost solution, but there is nothing else. Not even the circuit schematic is, unlabeled. There are no definitions of anything. The chip's there, and there's like a choke and whatnot, but that's about it. So the idea is to figure out how this works and then shorten it. Obviously, if you are not skilled with electronics, don't screw around with this. This controller board works on mains power, so there is 110 volts here, and it also feeds 110 volts all along the center of a light to the other end, because this light can be chained together into a long string like here. You can chain 6 of them all together. Also, even in the output stage, in a DC stage, you're looking at 350 volts DC. The currents are fairly low, 25, 30 milliamps for the LEDs, but again, don't screw around. You can give yourself a heart attack if you connect to that. It doesn't take much to cause an arrhythmia in your heart, probably 10 milliamps or less. So that's about that. If you want to do something like this, obviously find somebody who knows if you're not confident about doing it yourself. I guess I'm just going to figure out what needs to be done. Actually, I mean, I've spent some time prior to this recording and I already figured it out. In the circuit schematic, you have a voltage divider that determines a feedback voltage to the chip, and through other searches on the net I found that, and measuring the chip itself, that the feedback voltage is 1.5 volts. There is a generic or kind of like a standard formula for calculating the feedback voltage, and I use a different style data sheet from another manufacturer whose feedback voltage is 0.5 volts. Well, theirs is 1.5 because actually I measured it here. So you can use that formula to determine what is the voltage divider or the values of the resistors here in the voltage divider. And so I used the existing values in the voltage divider here, and it was 1.36 mega ohms, and so that was giving about 352 volts plus or minus 5. I needed 250 to have 70 LEDs, and so I put a 1 mega ohm resistor in this spot here, because this is 5.6K. That's set. So the two of them together still give 1.5 volts, and the drop is 1.5 volts on 5.6K, the voltage drop, and so this then determines how much volts you get on the output. And I've already measured, I have 250 volts. Perfect. So what's going to happen is that somewhere around here at number 70, I guess you can see that. Oh, there is 70 upside down. At number 70, I'll cut here, and then I'll probably cut as well this, and then wire everything back. I'll need to move these, because these are extensions for the live, for the mains line as well, and I'll need to scrape some paint from here and insulate and whatnot, and then see if that works or not. So we'll go from there. I guess more to come, hopefully without any smoke and special effects, or not so special, just effects. Stay tuned. Alright, we are back, and more progress has been made. The LED strip, if you can call that, because it's a hybrid circuit board, steel aluminum backing for heatsink, has been cut, and as you can see, those end connectors for the line, for the power line, has been transplanted, and the circuit copper has been trimmed from the edge so it doesn't touch anything. And now on this end and this end, we just need to bridge the wires so that this LED and that LED are connected in parallel and form one pair. And so after that, it's just going to be a matter of making sure everything is good, nothing is shorted, and testing it out. And hopefully everything works out. More to come. Here we go, another update. The wires have been soldered, McGuyvered jumpers, and they match the previous end of the LED strip, so that, you know, the last two LEDs are actually in parallel, and then they're wired in series with the previous the next two pairs. So what's left now is to plug this back in and test. So I'll be back soon. Well, looks like that the experiment worked. worked and the LEDs are up. I'm not sure if that's the correct brightness for them or not, but I'll take it because it's just a small area that needs to be light up in that front part, so looks good. Now just to cut this enclosure and put it back together, and then work on mounting everything on the ceiling. I guess we can call this a successful McGuyvering. Coming up more soon. And there we go. As they say, mission accomplished. The lights working, plugged into the power, and the outlet on the other end is also live. And let's just see how, sorry about that, how long it ends up being. Oh, so you can see that just under 3 feet, 35 inches, 3/4. Well, perfect. Now it needs to be installed, and the other light on the other end needs to be moved close to the wall, and then technically all the lights are ready for action, and it should be nice and bright. And well, I guess until we see that it's dark someplace else, maybe over there in the other alcove and this alcove there, but I mean, maybe not. We'll see. That's it for this project. Hope you all liked it. Again, don't mess with the electricity if you don't know how to do it. This is high voltage, both on the DC and the AC end. And so if you're not confident about hacking something like this, leave it to someone. If you know someone to help you out, if you need a shorter fixture, ideally, just buy a shorter fixture and be done and over with. Actually, let's do another segment here. Final look at the finished project. Now the layout is fully lit, and here is the light installed here. As you can see, this is the shorter piece, and then the other light has been moved further to the other alcove, and now there is pretty good illumination here in this entrance area. Before it was just dark here because that one light was just halfway across the backdrop, but now evenly lit everywhere. Looks pretty good and pretty successful. This area is also lit now, and there's going to be some industry somewhere eventually when we build more benchwork here. It's still in progress. Then we can take a look at the rest of the layout. Now that it's all lit up, this is going to be closed. It's going to be a removable balance, and then there is the other end there now. The alcove is now much brighter, making the layout feel uniform. The next project might be painting the sub roadbed maybe, or taping and painting the backdrops. We haven't really decided whether we're going to paint the backdrops or we're going to use photo backdrops. Both have their own pros and cons, so we still have to decide on that. But for the time being, there's still more benchwork work to do. I feel that I constantly do benchworking and never get to do trains. When are we gonna do trains? That train over there, it's still waiting to leave, because over there I have to mount a panel and connect a booster. It's waiting over in the gap here. There is the lens booster and then power bar for it, and so eventually I'll get to that as well. Anyway, for the time being, this is the final segment. Thanks for watching.